Bruh. Hello everyone. Welcome to Monday's stream. Hope you had a nice weekend. Mine was a little bit messy. Also, I apologize for missing Friday's stream. The real life intervened a little bit, so it was a little bit messy on Friday, and I realized I was really super late with the stream and I wasn't even halfway finished with what I wanted to do, so I ended up having to scrap. Oh. Sadly, stuff happens. Hi, Cheap Wheel. But yeah, in the end, I ended up working on more stuff during the weekend, so at the very least, I solved a couple of problems there. Oh. Yeah. Yeah, on Thursday, my partner and I we had tickets for theater, and the original plan was to go there and then come back in the evening, later in the afternoon. Turns out that the day was really, really nice, and we stayed out a little bit and had a walk around London, and it was really fun and it was really nice. Came back home and I realized that I had plans to do a bunch of stuff in the evening and on Friday morning, and I couldn't do anything until Friday morning. And then Friday morning I was really late, so in the end I started working, and then I looked at the time and it was already 4:30, and I was not nearly nowhere near finished. So the end result was, yeah, let's scrap it. It's Friday. Hi Andre. .NET, C# and Windows forums. So hilariously, I used to look at C# for a while, but I haven't written C# in 10 years probably, so but no, we're still writing Rust. We're still writing on the bleeding edge of programming language development, and it's still there. To be honest with you, I would love if people picked up C# again for GNOME application development. There is how's it called? There is somebody that is working on new language bindings for C#, generating them out of introspection data. I don't know what the status of their project is, but hopefully it will be public at some point, or at the very least usable at some point. It would be nice. You got timed out? Yes. I'm sorry. No links outside of GNOME.org. Sorry. I already had to deal with spam. Yeah, I would love to get better C# bindings. ASP.NET. Oh my god, no, 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 that's bad. Ah, oh, PTSD flashbacks. Oh. Yeah, at the time. God, yes, PTSD flashbacks. Oh, ASP.NET was around the time when I started looking into like HTML and PHP and other server-side stuff. And I remember when I started looking at ASP. My god, no, no. Some stuff is better left dead and buried. And possibly nowhere near an ancient burial ground. Oh. I'm not surprised that .NET stuff is pleasant. I mean, it's... From a language design perspective, it's always been a lot nicer than people ever gave it, especially people on the Linux side of things, ever gave it, like, credit for. It was already nicer than Java at the time, and Java, like, picked up a lot of stuff from there. So I'm... Oh, imp.rs file. Yeah, nowadays you cannot do anything with external, like with extensions, because the top level domain insanity has been growing exponentially. So anything that looks like a file extension will probably match the domain name now. It's so bad. It is so bad. We used to only have .com and we liked it. Fedora 36 and GNOME 44. Yeah, it's all beta, yeah. So the trick with Fedora is always find a place where you upgrade and everything seems to be working okay, and then try to delay the any update until you know for sure that some stuff works. That's why I use Silverblue, to be honest with you. I use Silverblue because I can roll back to the previous checkout. So if something breaks, well, at least I have a known working system. But yeah, I used to remember when... So before I switched to Silverblue, I used like the usual Fedora workstation, and I used to do the upgrade, the dist upgrade, early in the alpha like phase, and I would update basically every single day to get the very latest stuff working. And after the release, I would literally stop upgrading my machine. Because up until you get to the release point, there's QA going on. So stuff that breaks get noticed. After the release, QA is all focused on the next development cycle. So the end result is that sometimes I would just never upgrade a Fedora installation after the upgrade to the newest version, and then I would directly upgrade to the newest version. But again, this is why I really enjoy using Silverblue. It's I just leave it there. It's fine. It works fine. And then all my applications are outside of the purview of the system. So I can get bleeding edge applications and everything working correctly without ever upgrading my base OS. Which is, I mean, it's the usual experience on any other operating system, to be fair. When I had Mac OS installed on my other laptop, that's how I used Mac OS. That's how I used Windows when it was my gaming PC. It's just, okay, you upgrade the applications. The system stays exactly as it is for as long as it can. Otherwise, it's gonna be a mess. So, where were we? Remembering. We were on Wednesday. I did an update on the Amberol, the media player, the music player that I'm writing for GNOME, and well, it's not really for GNOME. It's not going to be like part of GNOME in any way, shape, or form, but it's targeting GNOME. And it's using GTK4, libadwaita, and all the bells and whistles of modern GNOME development. And the end result is that on Wednesday, I think, we had the very latest update with the UI recoloring based on the color palette of the cover art of the music that is currently playing. In between, there have been some changes here and there. So let me go to my desktop here and let's run the latest version of the code. Okay, so the basic UI is exactly the same, very simple. Compared to what was that, Wednesday stream, there's a new button here that shows the toggle to playlist. But in general, the functionality is exactly the same. The bug that resizes all the windows on X11 is still there. So let's add the music folder there. But now you can see there's a new style there. So the playlist is different. It's been styled differently. There's no more background and anything. The window resizes itself when the playlist goes away or appears. There's a little bit of delay there. I think I might be able to do something with the animation API, but I'm still not at 100% sure it's going to work out correctly. But yeah, for the rest, it's mostly a bunch of it has received a little bit of care in the in how the UI is laid out and how it is styled, thanks to Alexander, the libadwaita maintainer, who did a terrific job at fixing all the little like paper cuts in the UI, which is great. We're not gonna play, but we're gonna switch here. You can see another thing that I changed since Wednesday is that I'm not using a solid color anymore. I'm using a gradient, I'm using the color palette to define a gradient of colors to recolor the UI. The extracting the color palette is fine, but I had to basically fudge a little bit with the coloring there, because determining the color of the text is always kind of iffy. Hi, vegan. Yes, GNOME is that Linux thing. But yeah, pretty much the entire thing is pretty much stable in terms of UI, which is why I decided let's refactor the internals a lot. Can GNOME run Rust without extra packages? GNOME doesn't need to. Well, Rust doesn't need any extra packages. Everything is compiled usually, but it depends. If you're using Rust to write user interfaces and you use GTK, the GTK toolkit for writing user interfaces with Rust, which is what I've done, then the dependencies are all there and you don't need much. You just need to edit your cargo manifest to include like various crates there, mostly GTK here, and then libadwaita. Nothing specific there. The libraries, the C libraries underneath it are already there if you're running GNOME, so all you need to do is add a dependency on the language bindings that lets you write GTK applications using Rust. It's the same thing that would happen with Python or like JavaScript or C++ or whatever. But yeah, you can write GNOME applications using GTK and Rust. It's I was about to say it's not that complicated. That is not entirely true, but yeah. It's not complicated in terms of setting up the environment. Setting up the environment is pretty trivial actually. You can use GNOME Builder, which is the GNOME IDE, and it will set up most of the environment for you, so you don't have to do anything. It will even literally create a template project for you, so you just have to edit a bunch of files and add your own stuff there, but for the rest is already pretty much done. And you can use Flatpak to package everything and then deploy it and let people install it. So to be honest, is actually pretty easy, that part. Dealing with how to write an application using GTK, Adwaita, and Rust, that is slightly different and mostly depends on your dependencies. So at the very beginning, when I presented this project like last week, I outlined the fact that it was my first Rust application using GTK. It's not my first Rust project, but it's the first project that uses a GUI. And also, since I'm a glutton for pain, I decided to make my first project also use GStreamer, which is the media playback and whatever library that deals with parsing media and like playing media. GStreamer's design and GTK design are fairly at odds. So it's making them interact with each other in a way that satisfies Rust and the constraints of GTK and GStreamer, and the type system it requires some explanations there. Can it run on KDE Kubuntu? Yeah, it can run on KDE and Kubuntu. I'm pretty sure I mean, it will run. It should look exactly like this. It shouldn't look anything any different. Ideally. Anyway, so the design. The original design had this quality of, let's have GStreamer tell the player state, which will then manipulate the UI to reflect the state of the playback, the state of the queue, the state of the in general where we are inside the media playback, which is how I would usually write a GTK application, because I am a GTK developer. This is how we think. GStreamer works slightly differently. GStreamer is heavily thread-based, which means that events can come from a bunch of different threads that compose. So a GStreamer application is basically just a pipeline where you plug elements together, you string elements together to create this pipeline. You create a file source, which is a representation of a file somewhere on disk, for instance, and then you plug the output. The input is the URI, and the output is something else. You plug the output into a decoder, and then you take the decoder, you plug the output of the decoder into another element that basically just plays opens the sound device and plays it, and if not the sound device, at the very least the sound server, where it sends the decoded output as a waveform, and then blah blah blah. And all of this stuff can happen on multiple threads. It doesn't necessarily happen in the same context. So the way all the elements inside the pipeline communicate together is on this message bus. It's a single pipeline where messages get sent over, and the way you usually use GStreamer, especially for complex pipelines, where you take like multiple input sources and you mix them together, and then you decode one and you record the other, and you can do very complex things. I mean, people use GStreamer to do signal processing and analysis for detecting gravitational waves. This is the kind of things GStreamer can do. Whereas we are not entirely interested in that complexity at all. We literally want, please give me a file, decode it, and then play it. Done. Doesn't do much. Still, the way it's done internally is GStreamer tries to transform the messages into actual object signals, which are just a very simple way of calling a simple function, calling a function. It's a fancy way of attaching a list of functions to a string name. I mean, this is how stuff like pressing a button works. You press a button, GTK does a bunch of stuff internally, and then at the end of the day, it will emit the clicked signal on the button. And on the button, you attach a callback to that. So whenever the click signal is emitted, you can handle it. For GStreamer, it's exactly the same, except the set of signals there is wider and more complicated. So the typical design of a GStreamer application is not the typical design of a GTK application. You are not sitting inside a main loop, and every time a UI element just lights up, you get a signal back. For GStreamer is slightly more convoluted because, again, all the elements can send messages on the message bus, which will emit a signal, and that can happen on different threads. So the way it's usually done for GStreamer is to have something that watches the message bus, or at the very least the various signals that are emitted in response to that, to messages on the bus, and then notify a specific thread that handles the state of your GStreamer application. So every time something happens, you watch for that particular message that you're interested in, and instead of manipulating the state directly in response to that message, you take that and communicate with a separate thread in order to perform some action, update some state or anything. And it turns out that Rust has a lot of these facilities, especially the glib bindings for Rust have a lot of these facilities, because Rust is fairly strict when it comes to multi-threading. In order to remove an entire class of problems or like issues with multi-threading, Rust is very much aware of what kind of data can be sent to another thread, what data can be copied to another thread, and what kind of data should not be shared across threads. And again, you can write a media player that doesn't deal with any of this. You can write it, and it's perfectly fine. It takes a little bit of weirdness in how you structure the types that you're using and how you move the memory from one thread to the other. Sometimes you have to use a bunch of wrappers around your data structures so that the data can be safely copied, or something like that. Or if you can force GStreamer to say, please emit all your signals inside this single main context, then you're just, you know that the memory is not going to be moved across threads. You just have to tell the Rust type system that, I know this looks dodgy, but trust me, it's not. which is a fun thing to do. Hi, Georges. But of course, when you start like that, you end up with a lot of other problems. The code becomes a little bit complicated. The code becomes, the rules of what can be called and the lifetime of what can be called becomes a little bit tangled. And it's not fun to deal with. So this weekend I decided, okay, I have a working UI and I have a working media player. Let's do the thing in software where we are basically replacing the jet engine while the plane is flying. Which is to say, I replaced the entirety of the media player, the music player engine of my application, and rewrote it to use message passing. So to use the same kind of design that GStreamer heavily recommends people use. So I actually realized that I need to delete something here. Yeah, I'm not using Fragile anymore. So let's see what I've done. First of all, I created a small subcrate inside my submodule inside my application. So I moved everything that is related to audio inside this directory here. And then I took the player API that in the original design was a jumble of the actual playback API and the GStreamer backend and the MPRIS like interface integration, so that we can control the media playback using the notification inside the shell, like this. The overall idea was to take that and basically explode it. So separate everything. Which is what I've done. I left a massive comment because this is how it works. So I left a massive comment that explains how the design actually works. And this is the sub module that I added. Okay. Oh, Georges, nice. New feature to Boson, nice. Oh, that's really fancy. That looks gorgeous. I'll have to try it. I'll have to try it later on. That looks gorgeous. So yeah, one thing that I started doing a while ago, because I forget everything, is to, whenever I structure the design of something, I usually leave a massive comment somewhere that tells me how the design works and why it's that way, because I literally forget about everything. So the way it's structured is, we have the audio player API, which is what the UI controls will manipulate. So whenever you play, you press the play button, whenever you press the skip button, and so on and so forth, you call API on this object. On top of that, we have the player state and queue objects. These are actual G-objects, which have properties. So the UI can bind properties between widgets and the state and queue objects, and receive notification when something changes. Inside the audio player, we also have a GStreamer backend, which is the thing that will actually play the audio. And then we have a couple of controllers there. One is the MPRIS and the other is the inhibit controller. These are ancillary objects that can manipulate the state of the audio player. So for instance, the MPRIS controller will be able to play, pause, skip, next and previous tracks and stuff like that. And the inhibit controller instead is a simple way of monitoring the playback state. So whenever something's playing, we prevent the computer to suspend so you can keep playing music even if you close the lid of your laptop, for instance. Oh, just 1 second, sorry about that. Sorry, my cat decided that it was time for her to leave the room. Is the media player very efficient compared to something in Python or something? Not really. The nature of a GUI application is that it will most likely sit there doing nothing 99.5% of the time. It's just a busy loop, waiting for user interaction. Additionally, even if you write in Python or JavaScript, you're actually calling into C libraries. So if you're calling into C libraries, you're calling into C, basically. So a media player is never going to do something computationally intensive. The main thing it will do will be loading files to extract their metadata and then hand over the location of the file to play to some C library somewhere. So it's not going to be more efficient or less efficient. The main thing is probably going to be slightly faster because, for instance, Python has to load a bunch of modules at startup. There is some inherent cost of setting up the... So whenever you call some C API from another language, you have to take the data inside your that is expressed in your native language, wrap it into some other format in order to pass it to C, and then whenever you get data back, you have to do the exact opposite. And there is some inefficiency inherent to that translation. Mostly memory, not actual like CPU or whatever. So again, that is an inherent inefficiency in the translation. Rust has a little bit of a lower cost there because of the foreign function interface, like API that allows a more straightforward way of passing memory from your program to C and from C to your program. Having said that, I don't think it's inherently more efficient or anything. It's just, well, I wanted to use Rust for my application. I could have written Python. Probably I could have written JavaScript, maybe. I'm more confident with Python than JavaScript, but I could have written C. It's the language I know best, but I honestly wanted to learn Rust in GUI application development capacity, mostly to see what was the state of the project. It has been growing a lot inside the GNOME community, and I wanted to see what kind of state we are in. So it was mostly to see what we could do. Again, this one is not my first Rust project. I have two other Rust projects that I maintain off and on, but I do. One is a pure Rust implementation of the shared MIME database that is used by any Linux distribution. Instead of parsing it with C, it parses a bunch of files with Rust to ensure the safety of what you're doing. I honestly haven't tested if it's faster than C or not. It's definitely safer. That I know for sure. Mostly because I've seen how the C parser is written. And yeah. Lots and lots of magic strings and stuff like that. But still, yeah, I don't think it's inherently more efficient, especially for a media player to use Rust. I think it's interesting in terms of maintainability in the longer term. I've noticed that a lot of programs that I write in Python or something like that have the tendency to run away from you after a while in terms of complexity. When they become too complex, it's harder to do refactoring or harder to do to keep the code base from blowing up. I maintain a complex Python application, which is the tool that generates the API references for GTK and other libraries inside the GNOME stack. And it's written in Python, and it's just an XML parser and that generates a bunch of static HTML pages. But it has to do it has to generate an abstract syntax tree of the introspection data, and has to generate a bunch of templates out of that, and do a lot of other things. And sometimes it's hard to understand what the thing is doing or how to modify it. I started adding type annotations all over the code base. It's not done yet. In theory, I could run a strict validation of the types, but in practice, it's really complicated. And I'll have to figure out if it's easier to deal with that. For a GUI application, yeah, I don't know if it would have been nicer to use Python in this case, or JavaScript. The other thing is that Python and JavaScript are inherently single-threaded, and they cope really badly with stuff that is multi-threaded, like GStreamer. And it would have been a little bit messier to deal with this stuff with Python or JavaScript. So yeah, probably I wouldn't have opted for those languages on this reason alone. Yeah, for instance, like let's look exactly at what I'm talking about here. So the player generates a backend here, which is the GST backend. And the GST backend just sets up a GST player object, which is just a wrapper around a bunch of complex pipeline that loads files and decodes them and plays them over the audio server. It has a bunch of signals. One is the warning signal, the other one is the end of stream signal that signals that you're done, and then you have the position updated signal, which tells you, hey, the song you are playing advanced of X amount of data, X amount of seconds. The end result is that you have these signals here. They happen in the same main context as the rest of the the main context of the GUI, so it's exactly the same thread. But if the old code inside Amberol had to take the player object, wrap it around a reference counted data structure that could be passed around so that the signal handler could interact with it in a safe manner. And all of that has been replaced by this, sending a message through a channel that is across a communication channel that runs across threads. Let's see if I can get the old. So we can do this, switch back to the main. So yeah, the old code had to do something like this here. So the end of the stream signal here, we had to wrap the player around this reference counted data container and then wrap it around fragile, which is just a way to say this memory can be moved across threads. It might break, but it can. And then we had to get the pointer out of the reference and the reference counted object, upgrade it to an actual reference, and then we have to borrow the player actually, so that we don't accidentally delete it when it goes out of scope. And then inside it, in order to deal with all this code, and now all of that is gone. Switch back to message passing. All of that now is gone, because now we just, hey, send this this value, which is an enumeration value, through the channel, and the channel has been set up by the player itself. So we have a single process action function that basically just, whenever you get this message, do this. Whenever you get this message, do this, and stuff like that. How do you implement MPRIS support? Is there a Rust crate available for that already? Yes, there is. It's in the GNOME GitLab as well. Let me see if I can find it. So this is the documentation. The MPRIS player here. Let me see if I can find the home page. Yep, it's already here. It already does most of this stuff. It wraps the how's it called, the dbus API. It's incomplete yet, so it doesn't have the track list, doesn't have the playlist stuff, but it's enough for you to deal with the permanent notification in GNOME shell. It needs documentation, really, because it's heavily undocumented. Also, the MPRIS API is not great. Yeah, I think it has been designed with KDE in mind more than GNOME. The other thing that I don't understand is it has a raise message. So whenever you create an MPRIS like player, you have to pass the desktop entry so that the shell or whatever else can match the sender to a desktop file. It's great. It's perfect, right? And then whenever you press the notification, it should, in theory, it will send a message to your application saying, please raise your main window. Why? Why? No. Why? What the fuck? Inside GNOME, it should be the shell doing that. It's a massive layering violation. I mean, I have the MPRIS controller here, and the MPRIS controller sends a present message here, and then the player object will have to get the application singleton, get the active window, and then call present. This is the player object. Doesn't do anything with Windows. Why is it doing this? And other applications, especially ones written in Rust, they will have a separate channel that will manipulate everything from the application side of things. But it's mental. Why are you doing this? Yeah, yeah. I mean, it's nuts. It's how do we open code an how do we open code a media playback like API for every single media playback application in existence, and then do it over dbus? And it's like, it was around the same time when, yeah, but also the idea that you have to create you have to own a name on the bus with the exact same name prefix as MPRIS in order to what? It's just, I don't know. Just in order to filter stuff? What? So I think MPRIS is it's in the same, it was designed in the same era where the KDE status notifier API was designed, or at the very least right after. I don't remember how old is MPRIS. Let me double check. MPRIS specification. Oh yeah, 2005, 2006. So it's around the same time. So it's bonkers, and clearly was designed by the Videoland team because it's super complex. But yeah, it's I have no idea. I mean, you have to expose an object path. Okay, that's fine, but also you have to own a specific unique bus on the unique bus name with this prefix and your application after that, and it's like, what on earth? And then you have multiple instances, so you have to append the instance identifier. It's just, what? Yeah, it's clearly something that was designed a while ago, and yeah, we have to keep it. It's hilarious though. It's honestly hilarious. But yeah, luckily there's a Rust crate that implements all of this, or most of this already, so I don't have to care about it. It would be terrible if I had to care about it. Hi, Latira. But yeah, the mechanism for like communication at this point is pretty it's pretty simple to hold in your head. You create a channel here using the main context, and you define the property for that, so it's fine. We use a default property because we are communicating with GStreamer, and GStreamer has a needs a little bit of a it cannot be a low priority like communication channel. And then in order to do that, you create the sender receiver pair. You keep the receiver on the main object end, and then you say, okay, I'm going to attach this closure here, so whenever I get a message out of the sender, then I will process it, and this is where you process the thing, and you keep it alive here. That's it. On the sender side, you have, for instance, the MPRIS controller. Whenever you receive for instance, the play signal emission, you send a message here, and that's all there is. There's nothing really more complicated than this. It's not complicated in terms of implementation. From the implementation side, it is actually pretty simple, and it simplifies a lot of the complexity of dealing with the message passing stuff, because, as I said, you don't have to wrap any object, you don't have to capture any variable except the sender object here, and the sender object is already managed in terms of type system, can already be managed with multiple signals, multiple threads, and whatever. It's perfectly fine, it's perfectly safe. And then you have the send macro that deals with most of the crappy like boilerplate stuff, and all you do is send an enumeration variable, an enumeration like value, and that's it. No complexity in terms of memory management or the type system or anything. It's already there. What it requires is more of conceptual change in how you deal with this stuff. As I said, it requires you to think of your application not as like a single unit that basically just waits for events coming over. And as soon as something arrives and something happens, you manipulate it exactly where you received it, like you would for a GTK button being pressed. The change, the conceptual change, is you have an object that deals with all of this stuff, and it resides inside of a thread. And then any ancillary object that has has to change state or signals you that something has happened will send a message to you through the channel so that you can manipulate it. But the object in itself doesn't do anything except sending the message. So it's, when I say that new GTK and GNOME applications are mostly an implementation of a model view controller kind of design, this is the next step in the entire design process. Everything happens on like separate objects, and whenever something happens, you receive a message and you respond to that. So, and that message can come from a different thread, that message can come from a different machine even, or a different process, because it's an dbus IPC like message. So even if internally you know that something happens on the same context, same thread, because you told it to do that, or you wrote the library that to do that, you cannot assume that, and well, you cannot assume that for every single library that you use, at which point you have to decouple everything and just send messages across thread barriers, so everything works out that way. And this required like half of Saturday and a little bit of Sunday. Yeah, it's also nice because you avoid like layering violation. Yeah, basically this design allows me to write like the MPRIS interface, and the MPRIS interface does not at all change the state of the state of the player directly like you used to do in the previous implementation. So in the previous implementation, the player had the MPRIS and implementation and the GStreamer backend all together inside it, and then the GStreamer backend and the MPRIS implementation called API on the player object that owned them. This time it doesn't do anything like that. It will just send a message and the player will respond to that information. So from a GObject perspective, I could have made this a GObject and I could have added a bunch of signals. So whenever I got a signal from the MPRIS object, I would emit a signal on the MPRIS controller here. But then the signals happen in the same main context and same thread because they're synchronous. And the other thing is I would have had to implement to derive GObject inside for this particular object here. So it wouldn't have saved me anything when it came to sending messages across thread barriers. But yeah, this design is, again, the endpoint of creating your application as a view towards a bunch of data structures, as well as a bunch of controllers that actually manipulate the data structures. And yeah, again, that allowed me to decouple the state object, which was already separate and already a GObject. But at that point, the state here doesn't do much anymore. It only keeps track of what is the current song that is currently playing, whether or not the where is it? Yeah, the current position inside the stream. So I can use this state object here, connect to the properties here to get notification whenever they change, and update the UI as I was doing before. And same for the queue object. The queue object in the previous implementation, the queue object was literally just a list store, and all the queue information was into the state object, which was bad. Now the queue object is an actual object with a list store internally, but also has a bunch of properties to specify what is the current song that is currently playing, the repeat mode for the queue, and it basically just, you ask for give me the next song, and it will determine what is the next song depending on the repeat mode, for instance, and whether or not the song is the first one or the last one, and everything else. And this is all very much self-contained into a separate module here. And then the window, all it does is create a player here, a player object. Doesn't create a wrapper anymore, doesn't have to deal with that anymore. It just creates the player, binds the UI to the state, and then binds the UI to the queue objects, and then nothing else. It actually simplified a lot of the code there, simplified a lot of the interactions that the code had among all the bits and pieces of the implementation. So it is now a lot nicer. It's a little bit more code. I think the code base changed a little bit. Let me check. So first of all, you have to close all of this, and then we can do something like this. So originally it was 2,400 lines of code. Now it's just 2,800 lines of code. So we actually grew by 400 lines. There are a few more comments as well. So it's not entirely unexpected. And there is some duplication here and there because the player has to keep track of the playing state. Well, the player has to have API that wraps direct access to the state and queue objects, so that the window just has to call the player API and not call API on the state and the queue object to set up its own state. The UI only reads information out of the state and queue objects, which is a fair trade-off. I mean, again, the role of the state and queue objects is just to provide read-only information for the UI to update itself. Any change is only happens through the player API. Okay, so let me take a little bit of a break, and then we are going to look at try and plug that particular disaster of layering violation by using a specific channel there. Give me 2 minutes, and then we are going to go back here. Too many mugs of tea. Sorry about that. I had to do an idle meeting. Okay. So let's try and see if we can plug that particular disaster of layering violation and show how this stuff works. So the owner of the player is the window. Other applications use put the player on the application instance itself, and then pass the player to the window whenever they create it, because you can only have one thing. If you have an application with a single main window, it's hard to draw the line where you should hang objects that are global. It's hard to determine where that should happen. Like if this application had more than one window, then you would definitely hang all the single instance objects to the application instance, because there is going to be only one application instance. When you have when the application and the window are basically single instances, then there is not much of a difference anymore. You can do pretty much whatever you want. In this case, I don't want to pass around the player object. I want the application to be as simple as possible, because everything is going to happen on the window anyway. Otherwise, I would have to move the channel creation from the window to, move the processing out of the player and into the window and into the application, and would be kind of odd. Okay, so right, so we have the audio player instance here, and then everything gets constructed and blah blah blah, and that's fine. So what we want to do is, whenever the window receives a message that is going to be like present, then we want to raise the window. So first we start with defining an enumeration type with the actions that involve the window itself. In this case, we only have one action that is going to be like present. And after that, we need to create the channel for that, for the communication to happen. So we do exactly what the player does here. And we create a channel here. We also create a new one. We still use the default priority because, well, whatever, it's fine. So whenever you create a channel, you get two objects back. You get the sender and the receiver. You should hold on to the receiver on your end and then pass the sender to whatever object you need. In this case, we create an audio player and then we pass the sender to it. But we also need to keep the receiver on our end. So receiver here. We can do exactly what the player does, which is use a ref cell. Like this. So we keep the receiver with a different format there. Let's go back to the window here. And instead of using playback action, we use window action. So the receiver is also typed. For that, we need to use this. The receiver is also typed, which means that you can only send values from this type over. So you don't accidentally mess the message passing there. So here we create the wrapper around it. Here we go. And we start the receiver here. What else? Yeah, we need to modify audio player to accept sender object here. So we have to go here. And we call it win sender or window sender. And it's going to be a sender for window action. So for that, we have to store it here, window sender, and the sender, window action, and then we need to import sender, receiver, and we have to add the, we need to add the window action enumeration here. So we have to do this. And then window. And then here. We start the window sender there. Right. So whenever we get the present action here from the MPRIS whatever, or from any other object. So the nice bit here is that any generic like controller that we have that sends a message to present the window will go through the exact same mechanism. So we do this here, self, and then we can remove all of this. Okay. And now inside the window, we have to set up the channel, the communication channel. So we go inside the constructed here, and we do what the player does later on with this. Yeah. We can actually take this and then go inside the window. Here. Object. Stop channel. And then we do this. Okay. This is the receiver. Yep, we borrow it, we take the content, we attach it, and then we do this process action, and then we have to have a process action function. And then we do exactly what the player does here. We do a match. We remove all of this. Window action, present. And then we call present on ourselves. Okay, this will likely explode because I've coded it completely blind. So it's going to be fun. Oh yeah, thank you, Alatier. Yeah, ref cell option T is just one cell. Yes, I actually am planning to replace a bunch of stuff there with that. Right, this has exploded as I expected because I completely forgot that I have to include ref cell. So it's going to be cell, ref cell, and RC here. Again, it will explode. Yeah, I'm not going to. Why am I doing this? This is not GObject. So this is going to be window sender. And this is here. This is a GObject itself instead. This is a private field. What? Why? Oh yeah, because I'm dumb as a bag of bricks. Okay, it's building, seems to be done. So if we run it, it doesn't explode. So we add a folder here. Okay. So now we go back here. Yeah, 1 second. I have to mute myself so I don't accidentally DMCA myself. Here. And here we go. Yep, it works. I'm shocked and appalled at the fact that it was this easy. I could have written this like immediately like that. Why didn't I do it? But yeah, the mechanism as you've seen is not that complicated. You have to create the receiver and the sender receiver pair, and then set up the attach function to the receiver on one end, and then on the other you send stuff. So right now I'm doing a double message passing, but, and this is important, I removed code that deals with GTK and GIO from the player there. Let's see if I can get I don't have enough of a log. So let's close it. I need to see if I can get the build. Yeah. Now I can remove a couple of unused imports from here, like GIO and preview. And now I have fewer things to care about. Again, it's just a way to simplify the code base so you don't accidentally end up doing layering violation. Like, I have a message here, the controller, the MPRIS controller assumes that the implementation can just poke at the global state of your application, which isn't a great assumption to make. So what we do is essentially just, okay, we received, we can also rename this. Instead of present, we can call it raise. So it's actually, or call it raise window. Or we'll call it raise, it's fine. So we rename it and we call it raise here. And then inside the MPRIS controller, we use raise and the player, yeah, raise, and we call present here. And inside the present, we send present here. I mean, we could even move this directly inside the process action here, but I find it a little bit, yeah, it's a little bit dubious. I prefer to hide this stuff. And then again, this will send a message to the window, which holds the other end of the channel. And in that case, we don't even need to do weird things like getting the application singleton and whatever else. We already have, where is it? Yeah, we already have a window here. So we just call the API, the present API on the window instance, and it's done. And we don't have to care about the memory management of the entire thing. We don't have to care about the whether or not the type safety is involved, because all of this happens in a very specific scope and with very specific objects involved. And even the message passing is type safe because the receiver and the sender are bound to a specific type as well. So we are not going to accidentally send other types of actions if we confuse the sender object. And yeah, we addressed a layering violation there. So right, so let's save it. Bounce playback action raise to window, avoid layering violation of the playback action. looking at the default application and window singletons. Instead, it's message passing to get the window to raise itself. And here we go. There's a nice merge request there. Let me see. So let's go to the here. Where are you? There. So there's a very nice message passing. There's a very nice merge request here that we can merge when it succeeds. It will address this issue. In the end, I didn't go with this design. Yeah, so my original thinking about this design was hang everything off of the application singleton. It would have made sense. Like, for instance, we wouldn't have needed a separate channel for the bouncing the message from the MPRIS controller to the window from the player, because if the application is holding everything, then we can simply just raise the current window. Done. The application knows it. The cough. But as I said earlier, it's kind of hard to determine whether or not some stuff should be attached to the application or to the window if both are singleton objects. For instance, if we had everything, if we had the player attached to the application object, then the application would need to get the window and then manipulate the window itself, or call a bunch of API on there, or we would need to pass the player object to the window so the window could manipulate the player with its own UI. I mean, it's possible. We can pass the player in the audio player instance from the application to the window, because it's a reference counted object, and then it's just a matter of cloning the instance, and then the window, instead of creating the audio player object, will take it when it's constructed. It's just a little bit more iffy because the window is an actual G object, so you have to modify the constructor there. So you have to create an instance using G object and then attach the audio player to it. It's, yeah, I don't particularly like that design. It's kind of meh. So instead of doing this, we just debounce a message from one channel to the other. It's probably a little bit less efficient, but more it's simpler to understand. I mean, otherwise we would have needed, so another way of doing this, and yeah, this is something that other applications I've seen also do, is let's create the channel on the application instance, and then we pass the sender to the window and then to the player, and so every message coming from the GStreamer backend or from the MPRIS controllers will be routed to the application itself. Make the player a read-only property you can set on the window. Then the player will need to be a GObject as well, which is not currently. It's just a Rust object. So yeah, I think there are a bunch of ways of doing this. Right now, for me, the simplest way I could find was to encapsulate all the message passing directly inside the player object, and then modify the state from the player object so that the UI could be updated. This requires an additional channel between the window and the player, so that the player can raise the window. If we didn't have that particular problem, because the MPRIS implementation in GNOME Shell, or in general the MPRIS specification, was not as bonkers as it is, then we would not need to raise anything. The GNOME Shell knows what kind of application is opening is handling the notification. It can raise its own window. It should be, I mean, it should be immediately obvious how to deal with this stuff. You should not be sending raise messages there. What's the point? When you create an MPRIS controller, you have to pass the actual desktop file and the application ID. So the shell should know what to do in that case. But yeah, this stuff happens because everything has to be componentized, and everything has to not know what happens inside the system, because it's the Unix way. It's the Unix philosophy. And this is how you do not build an operating system. But yeah, I mean, and in the end, I didn't go for this particular design, but it's kind of similar. Instead of being on the application, it's on the player side, and it's all there. And that's it. We have a few other issues there, like shuffling, a UI style review, and defining UI states. Defining the UI states is kind of part of the player and the state here. So I actually think this can be closed. This is pressed by the as part of the restructuring of layer and state rights. And what else? And the UI style, I think with Alex's changes, I think the UI is not a disaster anymore. We are using the proper style classes for most of our UI, so I'm actually pretty happy with it. I mean, the UI is still like a disaster zone, because I have no taste whatsoever. But it behaves correctly, and it's actually pretty good. Like in appearances, this is not white or black background list view anymore, so I'm pretty happy with it. So let's also close this. I'm fairly sure that if anybody else wants to do a UI style review or tell me that I have zero taste in things, then they can open a new issue. This one, paper cut fixes number 7. So and I actually, this one is going to be complicated, so I actually going to postpone it to the next milestone because I'm going to do a quick release. So I'm going to do a quick release of this. Yeah, I need to wait until the merge request is actually merged. The CI pipeline is not the fastest thing. Oh, also there is a problem. Rust format is raising a problem. Yep. And I should have known that. If I had run the script here, so audio player, there we go. Yep. Music taste reviews. Music taste reviews are not going to be subject of an issue. The issue will be closed instantaneously. Okay. So actually, I need to do a couple of things first. So if I want to do a release, I need to do a couple of things. The first one is I need to take new screenshots for the application's metadata, because the current screenshots are of the 0.1 release, which is still using the black and, well, the light and dark styles, and they don't have the recoloring stuff. So we're not going to take a screenshot of this because it's terrible. So we're going to add a folder here. There. And then we need to do the resizing. No. Yes. So we're gonna take a screenshot of this. There we go. And then we're gonna take a screenshot of this with a new color or different color. And probably another screenshot here. Okay, so we can close this. And then we go back here. Has this been merged? No. Reuse is running. Hopefully it won't take that long. Let's look at the pipeline here. It's gonna take, yeah, this one is gonna take long. Okay, so we have those. Let's switch back here, and then we are going to do this. Okay, so we are gonna move. Here's screenshots. No. The last three, sorry. So from 411, 50, 36, and we call it Amberol 1. Then we take the one from 20 seconds later and we call it Amberol 2. And then we take the third one and we call it Amberol 3. Okay, now we copy all the pings to my home server. And then we modify the app data here. Okay. Okay. And then we need another release here. It's going to be 02, release today. We are going to need a build to run the test suite, so we know whether or not the manifest is going to pass. I am pretty sure it will not pass, because the screenshot stuff is kind of blah. Oh, thanks for the follow, Engineer One. So the build has succeeded, but the unit testing will now tell me that I am a bad person. No, it actually succeeded. What? I don't believe it. This one is a typo as well. This is weird. But yeah, it seems that it has passed. I'm positively shocked. My experience with the validation of the app data file is spotty, to say the least. Sometimes the screenshot stuff will tell you you have extra like white space around like extra transparent space around the screenshot. You have extra pixels. Actually, it will tell you you have extra pixels, and you're like, and it's the screenshot that my system took. What do you mean extra pixels? It's all the pixels there are. So in a couple of cases, I literally had to fire up the GIMP and then literally just resize the image to fit the content to eliminate some like transparent pixels around it. It was awful. Yeah, at least doesn't complain that releasing from the future. Yeah. The validation mechanism is such a disaster. I mean, the specification itself is not that great. It's not made any easier by the fact that we have two validation mechanisms, and one of them, it predates the latest version of the spec and has no documentation whatsoever. Yay! Anyway. Okay, the Flathub build is running. This is XKCD. Why are you not working? CI pipeline is running. It's literally that. We'll have to stash anyway stuff. But yeah, and then we'll have to update the changelog as well. Okay. What else we've done? I'm now gonna add message passing to like what we changed. Yeah. Yeah, didn't do anything else other than this. So this is going to be actually this is going to be under the added fixed and well, sorry. So this one, it's gonna get copied here. We're going to 0 to 0. There we go. And then we're going to remove this. So we have no unreleased stuff. Cough, cough. Yeah. Side effect of Rust is not the fastest compiler ever made. Plus, it all happens inside Flatpak. Yeah, if we didn't rebuild the thing 3 times, yes. Sadly, that's what happens. I also need to remove like a dependency here, like fragile. So I'll have to also put this. I mean, I cannot complain. I used to work on Firefox. Building Firefox on your machine is no. It used to be faster to write some code, commit it, and then send the patch to the try server and wait for the try server to build your patch series and run the test suite and tell you back. And even if you like made a mess with C++, it will fail faster. So the people that complain that Rust is slow, they should be forced to contribute to a large C++ project. Well, a large playback, large C++, any C++ project, really. Ah, yay. God, I knew it would happen. I shouldn't have uploaded them. I hate this. I hate this. Pictures, screenshots, no. Projects. Open. Okay, so image. Crop the content. And here. This one should theoretically fix it. So let's save it. Export, place it here. Export, place it. And here, export, replace it, and export. So let's go back and do that again. So let's retry it. And let's spend another 6 to 7 minutes on this. Sorry, chat. I was concentrating on this. A discussion on MPRIS controlling boson, 1 hour start countdown. Yeah, why not? I mean, so theoretically speaking, like setting up all of this stuff is fine. You can use this to play music and things like that on stream, but you have to be very careful about the music you choose. Otherwise, you'll get DMCA to death, especially on YouTube. Twitch doesn't give a fuck. Well, at the very least, it didn't used to give a fuck. These days, a little bit more complicated, but still. But yeah, one thing that I wanted to do with Boson is literally being able to like send messages over dbus to control applications. But having an MPRIS controller inside Boson would also be interesting, because then you would be able to control any single MPRIS enabled application you have. Holy shit. It's already working? What the hell? Congrats. I mean, that sounds awesome. Are you basically installing an MPRIS like server? So you look at the registration on the session bus? Because that's interesting. I mean, I'm not entirely sure how that deals with sandboxing stuff. Though I think MPRIS it's a sandbox, like it's considered a portal, so it's a sandbox escape anyway. Right, yes. Yeah, you have to add media player to the sandbox, but yeah, no, it makes total sense. Yeah, and yeah, that's actually awesome. But yeah, being able to control the media playback using the Stream Deck is interesting, especially for people that don't have keyboards without the media keys. Like I got myself a mechanical keyboard that explicitly has an additional row for function and media keys, but I know a lot of the smaller media mechanical keyboards do not have those keys, and you have to remap them and do like weird shit. But yeah, that sounds incredibly cool. Congrats. Now you're just showing off though. Cough, cough. Yeah, I shouldn't have replaced those images. I shouldn't have done that. Why did I do that? Because I'm dumb. I need to namespace those images. Yeah, that would be an interesting use. Yeah, I mean, a lot of people that do a lot of streamers, they usually play play music from like sources that have how's it called, like non god, like royalty-free sources, and the not from local audio but from stuff like Spotify or some playlist on YouTube or whatever. But if you have locally, like local music that you own royalties for, so you can use it on stream, then having a local media player that you can control automatically from your Stream Deck is actually a lot better. Yeah, I agree. Multi-action are pretty cool. I haven't found a complex use yet, because most of my stuff is literally just pressing a single button to do a single action, because everything is set up already. But if I had a more complex layout, I would do that. Yeah, YouTube Studio does that, but also like for instance, you have like local music that you know is royalty free because you own it. Either you made it or you paid for it, you paid the royalties for it. Then not using another tab on your web browser to play in background is actually a lot easier. The other thing, yeah, not having to deal with that. The other thing you can do is like set up a bunch of other more complex actions, like hiding and showing overlays and stuff like that whenever you switch around. Yeah, no, again, Boson is a great application, honestly. I think you struck gold with that. Definitely feel the niche in the ecosystem, much more than a small music player. Yeah, I need to store the screenshots using the version so I don't accidentally overwrite them. Come on. Come on, Progress. I know you can make it. It's just 10 minutes. I know you can make it. Yeah, I mean, the GNOME platform has improved a lot. I think it's the feedback from application developers. So for a long while, we were focused a lot on feedback from our users. We were absolutely like laser focused on that because we're writing the operating system, and the operating system is essentially the thing that your users will actually see most of the time. And we were also the people writing the core applications, so we were focusing on user feedback on those. But the thing that really changed a lot is then when we started getting more feedback from application developers that were using our platform. And our application development story has gotten a lot better since then. Oh yes, finally. Yeah, a lot of people are constantly saying, "Oh, GNOME doesn't listen to our users," and we actually do. We listen to our users far too much. We do listen to our users far too much, and we concentrate on that instead of concentrating on the people that are making our platform, that are using a platform. But at the very least, we are making a platform now instead of just making an OS, so that's good. Okay. So let's stash the changes. Well, and git stash. So IO screenshot Amberol. Okay. Okay. And here we go. Now we need to do something a little bit different. In order to dist, we need to do a local build outside of GNOME builders like cache. Yeah. We're also incredibly knowledgeable of what is available, not sure how it is for new people. That is true. That is absolutely true. It's kind of one of the things that we try to address with the new developer documentation website, which has an entire page dedicated to exactly that, to explain what is available, what are the components, what they do. It's not perfect. It's not great, but it's also the best thing we can do at the moment. Yeah, I know that I can do a build terminal and meson this in there, but I do prefer this because I'm old and set in my ways. But thank you anyway. Yes, it's true. You can open a build terminal. What's it called? It's not here. Yeah. Here. And you are inside the environment. But yeah. Again, I'm old and set in my ways. I'm older set in my ways, said after writing an entirely new application using a completely different language than the one he's used to. But for build systems, I'm terrible like that. Now that I managed to successfully eradicate most of the knowledge, most of the part of my brain dedicated to the knowledge of autotools, I am now 100% basically just set into the Mason build system. So I always do exactly the same thing. Yeah, I know. Yes, I did port a lot of stuff to Mason, and yes, I wrote a new documentation system. That's just because I ran on spite. I mostly run on spite. So if something spites me, I usually just spend the most amount of time I can and time, effort, resources, whatever, to rewrite it from scratch. Right, so new release, the process. It's running Mason dist. What it does is it takes a snapshot of the entire thing, including the cargo, well, sorry, the crates that we depend on, using this script that basically vendors the everything. So you don't need to have a network connection to build from a tarball, from the release tarball. This is going to be especially useful because we are going to publish the release on Flathub. I was keeping it under wraps, but yeah, Amberol is now on Flathub, and it's going to be published there. So the release is going to happen now, and then will be available on Flathub pretty much immediately. Well, not immediately. It takes a little bit to build the thing, but ideally it will be available immediately. There is already an Amberol release on Flathub, if you look for it. But it's... I recommend waiting a little bit. But yeah, it was approved yesterday, I think. Took a couple of days. Honestly, it's been the easiest process ever. Cough, cough. Just published the open a merge request with the manifest and then waited for somebody to review it. It was super easy, super quick. No hassle involved. So I'm pretty happy with how it worked. I always forget to put me inside in here. Do not disturb. Yeah, that would be another amazing thing to add to Boson. Interaction with the shell, and just having a button that says please do not disturb, or a multi-action that says do not disturb as soon as you start streaming. That would be amazing. Hint, nudge nudge, said with the maintainer reading the chat and listening to the stream. But yeah, that more integration with the shell would actually be very interesting. Being able to communicate with the shell, like a button to take a screenshot or a button to set the do not disturb. There's an interesting point if OBS should do it. I don't know. It might be a good thing to do. What the fudge? Oh, the vendoring shit? Why is Reuse doing this stupid stuff? And why is it doing it now? OBS Studio redesign. I've seen some screenshot lying around that made me very interested in it. Want a button to start compiling? Yes. You want a button to fix all the bugs. Okay, how do I ignore stuff? Why is Reuse just not ignoring shit? Build should be completely ignored. It has a git ignore file. What the hell? Wait, what? It should have a git ignore file. Oh, what the fudge? Yes. Okay. Probably an older version of Mason. Why the Okay, so. Of course, it will take another age and a half. Yeah, the discussion. Yeah, it's. I mean, it's an interesting like idea of redesigning the UI of OBS. OBS is clearly a complicated application with a long history. But I've also noticed a lot of people just not complaining about OBS, but basically, so with the advent of a lot of streamers and a lot of people using OBS to stream on Twitch and YouTube and whatever, OBS has definitely been exposed to a lot more people that are less into the aspects of producing video and more into the I need something that I can understand so I can immediately stream. But yeah, I think a lot of people are starting to realize that OBS might need a refresh in the UI department. It's less geeky and more platform for people like doing their work. GDK for the UI designer embedded Windows support that consider important to it. That would be amazing and also super complicated. The UI designer side is complicated, yes. And better Windows support, I think we do have better Windows support than we used to, but it's still far away from being like a instantaneous like turnkey kind of situation. One of the things that I know the Windows backend maintainers wanted to do was to publish the binary builds out of the CI pipeline in both for MSys2 and for MSVC toolchains. So ideally, you would do that. Well, yeah, the GNOME interface guidelines are actually really good. There are people saying that like basic libadwaita applications do not look out of place on Windows and Mac, even though they are very much like GNOME applications, which is true. But I think that's just because the style these days is similar across various platforms, and it's older applications that stick out a lot more than they used to. Older applications that are ironically based on how we designed user interfaces back 20 years ago, like early Windows 98, Windows ME, whatever, prior to Windows Vista or around Windows Vista. These days are very much weird on every platform. They look out of place on Windows, they look out of place on macOS, they look out of place on Linux. So it's yeah, it's an interesting problem for many applications. I mean, OBS is not that old, but it's been clearly designed to fit in with a very different set of interface guidelines. Yeah, all platforms seem to have converged on flat and monochromatic for now. That is true. That is kind of a shared design ethos at the moment. Until they invent board again in 5 years. That will happen. That has always happened. I mean, the Windows 95 style of user interfaces lasted less than 10 years. It was already going out of style with Windows XP and Vista. So OBS was not designed. They were just piled together over time. Yes, I mean, a lot of geeky applications are exactly like that. They just get piled on feature upon feature. It's what happens. I mean, it is what it is. Docker is different. Docker has always been a demo of an idea, and then somebody built a business model around it. But it's always been a demo. The trick is selling out before people realize that you're shipping a demo. They have some really smart programmers in the community, but not many designers. Show me any free and open source software that doesn't share the same problem. The only thing that sets GNOME apart is that we generally listen to the design team, to the point that a lot of the people in the community understand that the design team is working with you, but it hasn't been that way at all the time. So it's not weird that happens. Also, it's difficult to have designers join a free and open source software project. It's hard to attract them, just like it's hard to attract documentation writers, just like it's hard to attract like graphic designers or people doing like engagement or community management or anything else. It's a hard skill. And we self-select for clever programming types. Yay. Okay, that worked out. That was a bug well, that wasn't a bug. That was a problem with the version of Mason. Newer version of Mason, like 0.62, drops an ignore file inside the build directory automatically, so it gets automatically ignored by any tool that uses that. Older version of Mason didn't do that, and apparently I had an older version of Mason still installed in my system, which is weird. So okay. Here we have a release. Now we need a flag, and I need to have here. So let's tag it and bag it. Okay, this is the release. Now we have to modify the Mason build to bump it up to 0.1. Okay, so now we push. And we create a new release. Okay, so deployments, releases, new release, tag 02, Amberol. We still consider it alpha. And we add a milestone there. Let's use this. Okay. And then we attach a couple of files there. So projects, Amberol, build, mesentist. We attach these two files here. We attach the files to the release page because then we can download them from Flathub. So this is the preview. This is the okay. We create a new release here. Then we copy the link to this file. And we have to go into here. So let's close this. Okay. Let's open Vim from inside another. Let's open a text editor from another text editor. Editorception. So the URL is going to be different here. There we go. The checksum is also going to be different. There we go. Here. Let's copy it. Eight to 020. And okay. Let's see here. Okay, GitHub, Flathub. There's a new one here. This is automatic. The Flathub buildbot should pick it up and immediately deal with it. Let me see. Build. Yep. If you maintain anything on Flathub, this is the build from the buildbot. So it's building on two platforms, x86 and ARM 64-bit. So it will be available soon-ish. But yeah, this is how you release these days. Yeah, if you have a Linux application and you publish it on Flathub, this is basically how you do a release. It's pretty painless, even for complex things like Rust-based projects. Rust-based projects have the added complication of depending on a bunch of additional modules that typically on a normal system, on a normal build, you have to download from the main repository, the crates.io repository. But Flathub does not allow you to contact the network when building your application, for security reasons, for reproducibility reasons mostly. So to avoid that, normally if you have a normal application built using C or Python or else, you list all your dependencies inside your manifest. So instead of just listing your application here, you add all the dependencies here, and that is fine. That's perfectly fine. The downside of that with Rust is that you cannot do this. So you have to distribute the tarball with all the dependencies, the Rust dependencies vendored inside your project. And here you would only list the C libraries that you are using through, I don't know, like a Rust binding. If you don't have that problem, instead of using a tarball and SHA-256 for the contents of the tarball, you can point to a tag and a commit object inside a repository. And that is a lot easier to deal with when it comes to updating stuff. You don't have to do a dist with a tarball and everything else. Yeah, there's a crate generator as a tool. I think I saw it, but I honestly haven't had a good experience with that. Yeah, me neither. I don't know, maybe it works for smaller projects with fewer dependencies, but as soon as you start adding stuff like things that have recursive dependencies with a lot of other stuff, it gets meh. Oh, the x86-64 build was successful. The ARM build will take a little bit more. Yeah. Yeah, I think in my case, I think it missed a bunch of like recursive dependencies, and what it downloaded was weird. Cargo vendor was a lot better than that. Wait, yeah, it's because in my manifest, in my cargo manifest, I have a couple of features, and the vendoring script for Flatpak didn't deal with features that well. If you don't have any features and you have fewer dependencies, then it's gonna be fine, but yeah, or it might be fine. But yeah, I need a couple of features there. Let's go back here. Yeah. Yeah. Oh, that was a good release. That was a release well done. And at some point it will be available on Flathub. I mean, Yeah, the secret one is here. But soon it will be 020. So. Yeah, this thing is gonna give me the installs over time and downloads here is gonna give me an anxiety attack. It's like the GitHub activity grid. Oh. The build is finished, and that's it. Do we want to test it? Let's test it. Okay. There we go. This one is still one. I need to run it probably. Why is it still doing that? No. It's probably it's because I have it. Yeah, it's in the test. Yeah. I have it. I have too many of these installed. I already had it locally installed in a couple of places. It's usually messy. Perfect. Okay. Unless I completely fucked up. So, no, 020. There it is. And there we go. Okay. So we can publish it. Yeah, I had it installed in my system. I had the previous like Scratch build from the the submission merge request installed in my system, and that is not a good plan. Yep. And that is how you do it. So it will take a little bit to get updated to the new version, but it's gonna be fine. Yeah. Let's switch back to my head here. So did an explanation on how the refactoring went with the new message passing implementation. Modified the message passing to give you an example of how it's done, and then did a release of Amberol. So 0.20, it's going to be available on Flathub pretty soon. So if you want to test it out, just remember it's still very much an alpha like project, so don't expect it to be amazing or anything else. It does what it says on the tin, and it might blow up while doing it, so buyers beware. I have a couple of plans in the can for it. Apart from the implementation of the shuffle, I also want to add a little bit more caching there, and maybe, just maybe, be able to not index your music collection, but at the very least not hit the disk every time you want to add new songs. So basically have storage, a cache storage of the music and metadata, so that if you, after a while, it will build up your music collection, or at the very least something that resembles your music collection, without having to index it all the time. So that's basically one of the plans that I'm thinking about right now. But it's still going to be a very simple music player, very much in the tradition of Winamp and Muin. Doesn't do anything fancy, doesn't do anything other than play local songs. It better be bulletproof. I'm requesting a refund. Feel free to ask for a refund. I'm sure I can find $0 to send you. But yeah. So I think on Wednesday, so the day after tomorrow, I'll probably just spend some time working on the shuffle implementation. I have a couple of rough ideas on how to make it work without essentially just figuring out what is the next song that you're gonna play at the very last second. Like use a pseudo random number generator to figure out what song to play next at the time of call. But mostly the interesting bit is going to be displaying the playlist in shuffle mode. That's going to be fun. I'll have to figure out a sorting mechanism that does that. Other than that, time for the usual outro for the stream. If you enjoy watching me struggle with writing documentation, struggle to writing application or toolkit code for GNOME and free software, then why not subscribe to my YouTube channel? Otherwise, if you want to watch me doing this live, then follow me on Twitch, twitch.tv/Abassi, and you'll get a little notification every time I go live on Twitch. That usually happens on Monday, Wednesday, and Friday, unless something like awful happens, in which case I will probably just send you a notification on Twitter, so you can also follow me there to get your fix of me going live and writing code or documentation. For everyone still here, thank you very much for following along. It's been 3 hours, so wow. And yeah, always remember, if you have questions about GNOME or development with GNOME or anything else related to the GNOME desktop project or application platform, then just feel free to ask me in chat. I'm always happy to ramble on and on and on and on and on about the community and the platform, because that's what I do for entertainment. Other than that, have a fantastic rest of your day. Have a great beginning of the rest of the week, and I shall see you all on Wednesday. Bye.